Hello, my name is Mackenzie Neary, and I'm here to talk to you about spectroscopy of simple molecules that we did in lab. The introduction. Spectroscopy. We use spectroscopic techniques to identify an unknown compound. What is spectroscopy? Spectroscopy is the dispersion of elements or objects' light into component colors. This helps us to determine the chemical makeup of substances and what molecules are within them. Using IR and NMR spectra, we were able to determine what functional groups were within the compounds that we looked at. Here we can see the IR spectra, and here's an NMR spectra example. IR spectra is infrared spectroscopy. It analyzes infrared light interacting with a molecule. NMR tells us the hydrogen bonds, and how many peaks for the ratios. The procedure. The two pictures shown are given molecules on the left from our ChemLab notebook, and the left is a picture of a data chart for these molecules on the left and what bonds they look like. So here within the picture, this was given in our notebook. It was all the given molecules that we might possibly find in the unknowns. From that, we looked at the IR and filled out this chart about what bonds are within each compound. For the NMR spectra, we predicted this by looking at the peaks and to look at the hydrogen atoms within the elements or compounds. We also find the ratios from these peaks. So from the previous one, again looking at these molecules, we were able to then look at peaks in the NMR spectra. If there was one, there is no ratio because there's only one peak. And beyond that, you look at the number of each bond to tell us the ratios. Here are some examples of IR spectra examples, just two that were given to us. I used acetone and methanol. Here we can see it has a carbon double bonded to an oxygen and also carbons bonded to hydrogens. Methanol has an oxygen bonded to a hydrogen and a carbon bonded to a hydrogen. From there we were able to fill out a chart like this. My examples were methanol and then acetone, but I also used other ones from the actual example. Here are some NMR spectra examples. From here we can see the different peaks and charts. This one is ethanol, it has 3, and this one is methanol, it also has 2. Up here shows us the element, it has an oxygen bonded to a hydrogen and a carbon bonded to a hydrogen. Here it also has an oxygen bonded to a hydrogen and a carbon bonded to a hydrogen. From there we were able to fill out charts such as these, telling us the number of peaks and the ratios of each of the areas. The results. From the previous shown slides, we can fill out the chart to tell us what's needed. The predictions were found by evaluating all the compounds in figure 4. We used the IR spectra and peaks to tell us about the IR and NMR spectra. The unknown IR spectra. I had 50H, 50F, and 50K. Here were the IR. So 50H had a CH singly bonded, a C double bonded to an O, and then here were the results for the 50F and 50K. Going on from there were the NMR spectra for each. 50H had 3 peaks, 50F had 2, and the last one had 1, and here were the ratios of the areas. Reasonings for 50H. Because it had a CH bond singly bonded to an oxygen and had 3 peaks in a ratio of 3 to 2 to 1, we found that it was ethyl formate. I found that ethyl formate is found in the stingers of bees and ants, and also is the cause of raspberry sweet taste. Here's a picture of the actual makeup of ethyl formate. There's a C double bonded to an O and a C bonded to a hydrogen. Next was 50F. 50F had a benzene ring and carbon singly bonded to a hydrogen. It has 2 peaks with a ratio of 3 to 2. From this we found that it was paraxylene, although it wasn't exactly with the data because it had a chart or a peak that was not listed, but it was the one that was closest, and the spectra can sometimes make incorrect errors. Paraxylene I found is commonly used to make plastics, metals, and chemicals. It has many different uses. Here's an example. This is the benzene ring, and the carbons bonded to the hydrogen singly. And then 50K. It had a CH singly bonded carbon and a CCl bond. Through looking at that and the 1 peak with no ratio, we found that it was 1,2-dichloroethane. It's used in vinyl chloride, which is used in cleaning items, used to clean plastics and leather couches and things like that. Here's an example of the carbon bonded to this fluoride and the carbon bonded to the hydrogen. The results basically just restated. 50H was found to be ethyl formate, 50F is paraxylene, and 50K is 1,2-dichloroethane. From the data, we were able to find these results through the NMR and IR spectra. Conclusion, IR and NMR spectra can be used in everyday life to help us figure out what compounds are made of and see if they're in the proper ratio to make sure that there couldn't be a better compound better suited for a job in our future.